Hello, welcome back to the workshop. My name's Brent. In this video, we're going to talk about the tooling options I have available for machining shorter tenons on the spindle molder, from stub tenons up to about 50 millimeters long. All the tooling presented here today will be from Whitehill Spindle Tools, but will not be the entire collection of tooling they have available for machining tenons. Consult their webpage or give them a call to talk about the full suite of options they have available. Machining tenons on the spindle molder can be done very safely, provided all guarding is used, all PPE is worn, and safe practices are used. As well, please make sure all operators are up to date and current on their training. So let's get started. I suppose it's debatable whether or not the male half of a cope and stick joint is in fact a tenon. A lot of folks would call it a stub tenon, but there's enough conceptual and tooling overlap in the execution of the joint that I wanted to talk about it quickly. I don't do very much in the way of cope and stick, but before I had some of the other tooling options, I used to get high-speed steel knives ground for a limiter head such as this. You can get dedicated carbide insert tooling for making cope and stick, and that's great for people that are doing high volumes or working in man-made or abrasive material. But for the volumes that I did, this worked well for me. So you can see on this coping or scribing knife that there is a small kind of kitchen or cabinet door grade tenon there. If you use larger and thicker knife stock, you can get longer tenons. Now, to explain the limits of all that and how everything works is too much for one video, but suffice to say that even if you were to use a larger block with the thickest steel, you'd still be limited to a tenon of around 1 inch. Now, one advantage to having knives ground for your stub tenons is you can have features incorporated into the profile that might not otherwise be possible or practical. For example, and this is often featured in the dedicated carbide insert tooling sets I mentioned a minute ago. When you have the knives ground, you can make sure that the tongue cutters leave a very mild radius on the ends. Now, this can really simplify assembly. If you imagine you've got a really stressful glue up with, say, a complicated door, and you have a whole bunch of rails that all have to go into stiles before the glue sets up. I know a lot of people really appreciate having the chamfer on the end of the stub tenons, and also appreciate that the tooling does it for them instead of leaving it be done as a separate operation. So what are the pros and cons of doing it this way? You are very limited in your tenon length. You also have limited flexibility. Once your knives are ground, you're pretty much stuck with that. It can be very cost effective though, especially if you already own a limiter block like a lot of folks do. Getting a set of cope and stick knives is relatively inexpensive, but also this can be executed on a relatively light, low power machine. Okay, so the next three approaches I'll talk about are basically various forms of stack tooling. Now, stack tooling is where you install one or more cutter head on top of the other on the spindle. It's a very common machining strategy, not just for tenoning, but for tenoning, the first thing we'll talk about is stacking rebate blocks. Now, I don't have any pure rebate blocks anymore. I just use these combi heads from Whitehill Tools, which of course combine a rebate block with a limiter head. I've talked about these on the channel a number of times, and they'll work just fine. The concept is very simple. For most common tenons, you would stack two identical diameter rebate blocks on top of each other, and you just adjust the number of spacers in between them to suit the tenon thickness that you want. This works very well because many of these, though not all of them, have shear cut knives on them, as well as spurs for very clean shoulders and inside corners. And most of them all as well are carbide, so they last for a long time. In addition, this approach would employ tooling that you probably already have. The rebate block is the block most already have in their shops. Yes, you'd have to buy a second rebate block, but they're relatively inexpensive, and if you have a second machine, getting a second one is a pretty easy argument to make. But there are some disadvantages as well. Depending on the diameter of the block and some of the other build geometry, you're still limited to a relatively short tenon. As well, the most common rebate block is either 100 or 125 millimeter in diameter like this, but they're also usually around 50 millimeters high. So by the time you stack the two of them on top of each other with some spacers in between, you're using up a lot of spindle, and you're getting up to very close, or if not beyond, the height of the average most common spindle that would come with a machine. So depending on how you go about milling your tenons, this is something folks running smaller machines might want to think about it. Now, if you're using a big side-mounted tenoning carriage, or even one of the bolt-on ones that raises the stock up a little bit, this will be less of an issue. But if you're using a flush-mounted slider off the front, for example, or even a coping sled type setup, you need to verify that your machine can drop the lower of the two blocks down below the table sufficiently to cut the lower cheek and shoulder where you want it. Because if you think about it, it's going to be that lower block that cuts the lower cheek and shoulder for you, and you need to make sure that you can drop it down far enough to do that. As you can see on the smaller machine, even with the smaller blocks mounted, I wouldn't be able to do a centered rule of third tenon. Now you can get around that with a false table, but that's really asking for a lot of issues with accuracy, and I wouldn't do that. Okay, so what are the main pros and cons for tenoning with rebate blocks? You'll often get excellent clean results, especially with blocks configured for a shear cut, with the best being dual shear that remove material in both directions. And that's really best for the cleanest shoulders, especially at the outside surface. You'll also get, it's also a relatively inexpensive option because a second rebate block isn't that expensive. You'll also get long life, as carbide of course is very long lasting. And any jigs or fixtures that you build for this tooling solution will remain functional because the blocks are basically always the same diameter. Now for some of the bad, you're limited to relatively short tenons, but also the size and weight of this option might not be suitable for smaller machines. And even with a larger machine, you might not have enough spindle for the job. So let's take a look at this option in action. Okay, let's move on to my preferred method for making tenons these days, and that is with two stacked tenon discs or fixed groovers. These are by Whitehill tools in the UK, and these happen to be 200 millimeters in diameter, but they're available in 150 right up to 300 millimeters in diameter. So that's 6 inches right up to 12 inches, and in a range of 6 millimeters up to 30 millimeters. Many of them are available in a Z4 configuration, so that's 4 cutters around the cutting circle with 2 spurs on top and 2 spurs on the bottom. Many are also available in either aluminum or steel. Now using these is just about as simple as it can be. You just adjust the number and thickness of spacers between the 2 discs to suit whatever tenon you need to make. And much like some of the other tools, you get really clean cuts in the carbide inserts and spurs. In fact, the 30 millimeter versions available from Whitehill are available in a Z4 dual shear configuration, which gives you an excellent clean cut on end grain, even in the most challenging of wood. Also, where this is purpose-built tooling, you can get longer tenons than some of the other options. You can get tenons from your stub tenons all the way up to the better part of 5 inches, depending on the spindle size and the spacer diameter that you're using. So that's the good. The other side of it is these are pretty specialized tools, and especially for the larger versions, you'll probably only ever use these for tenoning. They may be more expensive than some of the other versions, and especially with the larger ones, you may need additional or different guarding. You'll also need a very well-tuned and robust machine. The larger diameter tooling has a habit of amplifying any imperfections in your spindle. Okay, on to the last tenoning approach that I use. You've seen me talk about these combi heads on the channel a number of times, so I'm going to go over this really quickly, but I will put a link in the description below to a video where I talk about these in more detail. These are the large and small combi heads from Whitehill tools. They've got pitch and sawdust all over them because I use these all the time. If you're looking for a cutter block that is a multi-purpose block but zero compromise in terms of performance, this is where you want to go. There's a large one and a small one. I'm going to talk primarily about the large one here. So you can mount these in a conventional way if you want, but these are also designed to be flush mounted either on top of a spindle or on a stub spindle like this. So as you can see, there's no spindle protruding through the top of the block. That means that you can form the cheek and shoulder of a tenon one side at a time by letting the tenon run over the top of the block. This effectively means you are not limited in terms of tenon length that you can form by the diameter of the block. Mounted conventionally, this is a 125 millimeter diameter block, you would be limited to a tenon length of about 1.5 inches. Okay, with the exception of the first option we talked about, primarily we've been talking in this video about square shouldered tenons, but this block does support coping or scribing tenon shoulders using the limiter portion of the block. Now these are some knives that I'm using for making windows for the new shop, so let's get these installed in the block and take a look. Now Whitehill has dozens of profiles available off the shelf, plus you can have knives ground for whatever custom profile you might want, but you can see how with the scribing knives installed, the block works very much the same way. Now I've used these blocks a lot for tenoning over years, so what are some of the pros and cons? Well, they're a very cost-effective solution, especially if you already own one of these blocks, but you'll also get an excellent cut and very long life with the shear cut carbide knives and the spurs. It also takes a lot less horsepower because you're only doing one cheek and shoulder at a time, but you can also achieve longer tenons for a smaller diameter block. Now the other side is it takes twice as long because you have to run them as stock past the cutter head twice to do both cheeks and shoulders. And the thickness is set by your spindle height versus using a set of precision shims, for example. So it takes a little while to dial in the perfect tenon thickness. And care needs to be taken just to make sure that the shoulders line up perfectly. So let's take a look at the large combi in action. If you have any questions about the tooling presented here today or are interested in some customized tooling to suit your particular needs, be sure to reach out to Whitehill at the coordinates in the description. Thanks very much for watching, and we'll see you next time.